Hi, Mr. Kitchen, Cobleskill, Richmondville High School Physics. In the screencast today, I'd like to show you this method for creating ray diagrams for plane mirrors. We are going to use a ray tracing method, and I've got the three little notes here at the top. You can pause the video at this point and copy those down. I'll be talking about each one of those as I draw my ray diagrams. So when you're done copying this stuff, I'd like you to work along with me and create this ray diagram for your notes. The first thing we're going to do is take our ruler protractor combo, and right here in about the center of the page we're going to draw a vertical line. The length of the ruler protractor combo is a reasonable length to use. It's about 15 centimeters. And we're going to label this line with M's at both ends. M stands for mirror. And because a line doesn't really give us a whole lot of information, we'll just put a little note down here at the bottom. This is our reflecting surface. The reflecting surface is our shiny surface, and that's where the light rays are going to bounce off. Now, I need an object that I can draw a ray diagram with, and we usually use a simple object like an arrow. So what I'd like you to do is find about the center of the left-hand side, and we're going to draw an arrow that's about 45-degree angle. The actual angle isn't terribly important, but I would like the object that we're going to draw, the arrow that we're going to draw, to be exactly 3 centimeters long to the best of your ability. So about 45 degrees, we're going to put a arrowhead over here and the fletchings of the arrow over there, so the arrow's got a tip and a tail. And now let me show you this ray tracing method. Now, as we said above, we need to draw 2 or more light rays from a point on the object and show their reflections. So we're going to start here at the tip of the arrow. I'm going to put a little dot there so that you can see it better. And the first light ray that I want you to draw is one, well, if we made this at 45 degrees, we'll just do a little bit less than that. I don't want you to get confused and think this has to go in exactly the same direction. So draw a light ray something like this. We're going to put an arrow on it aimed toward the mirror. That's my incident light ray. And now we're going to use the ruler protractor combo to figure out the reflected ray and put the normal on that line as well. I'm going to zoom in a little bit here so you can see better. And what I want to do is I want to put the hole that's in my protractor right over the spot where the light ray hits the mirror. And I think I've got things pretty well lined up here. We're going to make 2 little marks. The first one's at 90 degrees. That's for my normal line. And the second mark we make is for the reflected light ray. What we have to do is count over the number of degrees to my ray. The nearest degree is fine. So I've got about 37 degrees over here. And what I'll do is I'll just go to my 90-degree line, and I'm going to count over 37 degrees again. 10, 20, 30, 5, 6, 7, and I'm going to make a little mark. All right, those are all we need for the reflected ray and the normal. So I'll take this point right here. This is the one at 90 degrees for my normal line, and we usually use a dashed line for that. We'll put a little N there to indicate it's the normal, and then I can show the reflected light ray like this. As it bounces off the mirror, I'll put an arrow on there to show that it is the one that bounced off the mirror. And there's my reflected light ray. I'm really done with the first ray. Now I need a second light ray from the tip of this arrow, and I have a whole bunch of choices. I literally have an infinite number of choices. But here's a ray I recommend that you at least consider. Because if I send a light ray straight into the mirror, it bounces straight back. We don't really have to measure any angles if we do that. The angle of incidence is 0 and the angle of reflection is 0. So what we can do is take the 90-degree line on our protractor, put it right on our mirror, and then we're going to slide this up until I reach that dot. Get everything nicely aligned. Precision matters in these ray diagrams. And all I have to do is draw a single line like this, and that represents my incident ray, my reflected ray, and the normal. So if the light ray comes in like this, it's going to reflect like that. The angle of incidence and reflection are 0, and the normal is underneath there. All right, so that's basically a 3-for-1 when we choose that light ray. Now, the next thing that we need to do is extend the reflected rays behind the mirror. Well, here's a reflected light ray. This is a reflected light ray. So we're going to line up our ruler protractor with this reflected light ray. Make sure it's the reflected one, and we're going to extend it back behind the mirror. I'm using a dashed line again. Now I want to come past the point where it's going to intersect over here, because I'm going to take my ruler protractor. This is the reflected light ray over here. It's all the same thing. Extend that backward behind the mirror. And what I'm really interested in is the point where these two light rays cross, because that's where the tip of the image is going to be located. Essentially, that's what we're after. If you can do this, you can do the rest, because we're just going to repeat this process again. Let me show you how it works at the tail of the mirror, or the tail of the arrow. Put a little dot there just so you can see it a little bit better. I'm going to send some arbitrary light ray over here toward the mirror. Put my protractor over here. I'm going to make a mark at 90 degrees from my normal line. I'll count over 10, 20, 30. I have 37 degrees, whatever you get. Count the same number of degrees and make a mark on the opposite side. Okay? Same thing as we did before. This mark right here is for my normal line. I'll put that in and label it with an N. This one's a little bit tougher to see, but there's my spot right there. Kind of got caught up in this reflecting part. But I can draw this light ray over here, and that's my reflected light ray. Since I know this process now, and we got the ruler over here anyway, when we draw these reflected light rays, I often just go ahead and draw the extension behind the mirror at the same time. Here's the tail of the image, so I want to draw it up until I reach about this point, or a little bit past there. So I'll just do that. And then here's my reflected light ray, and here's the extension backward behind the mirror. Now comes the 3 for 1. I put my ruler here like this. I'm going to slide up until I just hit the tail of that. And I draw a solid line over here, a dashed line on the back side of the mirror, on the virtual side of the mirror. I can mark this. It's an incident ray. There's my reflected ray. We don't see the normal. And the point where these two light rays cross is right here. All right, so I'm going to mark those two. Now, that gives me the location of the image in the mirror. I'm just going to zoom in a little bit here. And take these 2 points, which I found behind the mirror, and the one on the top, all those light rays came from the tip of the arrow. The one on the bottom, they came from the tip. So I just fill in the corresponding points of the arrow, and I will label this as my image. All right, so when you come into class tomorrow, show me your ray diagram, and we'll see how you do. But in a nutshell, that's how you do ray diagrams for plane mirrors.